discussion of sequences, now we're going to go with some arithmetic sequences. And if you'll remember, that means that they add or subtract. They have a common difference. So learning the language of sequences. Sequences have their own notation and vocabulary that help describe them, such as term and term number. The questions below will help you use this vocabulary and notation. Consider the sequence -9, -5, -1, 3, 7, etc. As you complete parts A through I. Is the sequence arithmetic, geometric, or neither? Well, it appears to be arithmetic because I'm adding 4 each time. So what is the first term of the sequence? The first term is -9. When the sequence generator adds a number to each term, the value that is added is known as the common difference. So the common difference here would be -4, right? I'm sorry, it's +4. We're adding 4 each time through. Record the sequence in a table. Remember, a sequence table compares the term n and t of n. So we'll say we have n and t of n. So it would be something like this: -9, -5, -1, 3, 7. So 6 would be 11, and so on. Graph the sequence. Should the graph be continuous or discrete? Why? So this is where it really sort of gets into what we're talking about when we talk about a sequence. So let me go ahead and try and make just a really ugly graph real quickly. I'm not going to go too crazy worrying about all the conventions of it, but essentially 1 is going to be -9, right? I guess I can continue this thing along here. So 1 is -9, 2 is -5, 3 is -1, 4 is 3, 5 is 7, 6 is 11, and so on. So a couple things to notice about this graph. It should absolutely be discrete. We do not have a 1.2 term or a 1.5 term. Also, we don't have a 0 term. 0 is not part of the sequence. The sequence always starts at 1. Right? So that's important to remember when we go with these graphs. There's no negative, right? There's no negative term of the sequence. So that's really important to remember. So how is the common difference related to the graph? Well, the common difference is the slope. Write an equation to model the sequence. So begin with t of n. So what we'll say is t of n, and this is where it gets a little bit tricky, t of n equals 4n. But our y-intercept is not anywhere in the sequence. Our y-intercept is over here. It's out of the sequence, -13. This -13 describes this sequence, but it's not part of the sequence. And that's, I think, one of the biggest things that we need to understand is that the 0th term, this is known as the 0th term, is used in the equation, but it is not used in the sequence itself. So that's really important to understand. But you can see that this equation works. If I plug 1 in, I get -9. If I plug 2 in, I get -5. So again, this is outside of the sequence. I like to kind of keep it out of the n and t of n so I don't get confused with that. So what is the domain of the sequence? Well, the domain, again, is the inputs. It's 1, 2, 3. It's what's known as the counting numbers. There's no decimals, no 0, no negatives, etc. And then it says, what is t of n if n equals 0? How is the value represented in your sequence equation? So, again, what is t of n? What's my output? Well, it's -13, right? But how is this value represented in your sequence equation? It's the starting point of the sequence, but it's not actually part of the sequence. So maybe a little bit confusing. We'll see some more examples of that. So the next one, throughout this course, initial value or the starting point or 0th term will be used for t of 0, and this number will not be listed as part of a sequence. T of 1 is the first term and is the first number listed in the sequence. T of n is called the nth term in the sequence. So consider this sequence. What is the 0th term? Well, here's the first term, here's the second term, here's the third term, here's the fourth term. So if I wanted to go backwards to get the 0 term, it looks like it would be negative 7. What's the first term? The first term is negative 4. And what's the common difference? It is plus 3. So write an equation for t of n. So I will say t of n equals 3n minus 7. And again, that negative 7 is not part of the sequence, but it does help describe it. If I plug 1 in, I get negative 4. If I plug 2 in, I get negative 1, etc. So is it possible for t of n to equal 42? So I don't know. I mean, if I take this equation and plug 42 in for t of n, will this work? So I add 7 to both sides, I get 49 equals 3n. So n is going to equal 16 and a third. So there is no 16 and a third list. So we'll say no, it is not possible because, again, it's got to be 16 or 17. There is no partial. So is it possible for here when we use f of x and 3x minus 7? Well, yeah, f of x and 3x minus 7 implies this, right? A sequence, don't forget, implies this. So there's a big difference, right, between the two. Actually, I think I started that one below. I should have started it above. So above, I should have started below. So again, a sequence starts at 1 for the domain. It goes to 2, 3, 4, 5. Here we can have, if it's f of x, we can have a negative, we can have a 0, we can have a decimal, all those things. So that's really important to understand. So here we could have an output that is 42, whereas here we couldn't. T of n means sequence, f of x means not a sequence. So explain the difference between t of n and f of x. Again, t of n goes in one direction, starts at 1. F of x goes both directions, positive, negative, whatever, it doesn't matter. All right, let me go ahead and set up the next. She wants to create an especially tricky arithmetic sequence. She wants the 5th term to be 11 and the 50th term to be 371. So again, the 5th term will be 11 and the 50th term will be 371. That is, she wants t of 5 to equal 11, t of 50 to equal 371. Is it possible to create this sequence for her? Well, here we have a gap of 360. Again, here's our n and it's our t of n. So instead of change in y over x, it'll be change of t of n, which is 360 over t of n, which is 45. So if I divide 360 by 45, I think I'm going to get 8, but let's double check that. So 360 divided by 45, we do get 8. So that, yeah, I mean, it does land perfectly. Remember, it can't be a decimal, but it does land perfectly. So it looks like we're going to add 8 each time. Is it possible to create an arithmetic sequence? So yeah, we would say 6 would be 19, 7 would be 27, 8 would be 35, etc. And we would expect the 50th term to land on 371. Is it possible to create an arithmetic sequence to fit our information? It seems like it is. Is it possible, if it is possible, to determine the common difference, which we said already was 8, and the initial value for t of 0? Well, a couple ways we can do this, but I think one way we could do it for sure is just work backwards. So 4 is 3, 3 is negative 5, 2 is negative 13, 1 is negative 21, so 0 looks like negative 29. So we come up with this equation. T of n equals 8n minus 29. And what I would expect is when I plug 5 in, I would expect to get 11. So if I plug 5 in here, I get 40 minus 29 is 11. That worked. If I plug in 50, I expect to get 371. So 50 times 8 is going to be 400. 400 minus 29 is 371. So you can see that did work out. The other thing, well, anyway. All right, so 7 years, let's just jump on to 560 and keep going. I think sometimes it's just easier to get the next example. 7 years ago, Cody found a box of old baseball cards in the garage. Since then, he has added a consistent number of cards to the collection each year. He had 52 cards in the collection after year 3. So year 3, he had 52. and now has 108 cards. So 7 years ago was time 0. So 7 years is times 0. So I guess we'll say 7. He has 108. I hope that makes sense, like why we're doing that. So he found the cards here. This is where he found the cards. Since then, he's added to the cards. He had 52 cards in the collection after 3 years. So year 3, he had 52. And he now has 108 cards, which was 7 years after he started. So 7 is 108. So again, how many cards were in the original box? Well, let's go ahead and figure this out here. There's 56 cards that have been added over the last 4 years. So if I divide 56 by 4, I'm going to get 14. It looks like he's adding 14 cards a year. So this, and I'm just going to double check to make sure by adding 14 that it adds where I want it to. So I get year 5, he had 66. Year 6, oh wait a minute, 28. Yeah, I'm getting 14. So 70 should have 80 cards after year 5. He should have 94 cards after year 6, and he should have 108 after 7, so it landed perfectly. 2, now I'll just subtract 14 going in this direction. 2, he had 38. 1, he had 24. So 0, it looked like he had 10. So T of 0 is going to be 10. T of 1 is going to be 24. And it says how many cards were in the original box. I think it's T of 0 is 10. And write the first term of the sequence. So the first term of the sequence would be 24. Let me pause for a second. I'm not sure that I'm right. I hate this question because I think it's a little vague. So let me check the answer with what the book says. So I guess the thing I don't like is he actually had 10 cards when he started. It seems like it should be part of the sequence, but it's not. The sequence starts at the first year, right? So it's not that I have a problem with sequences. I just don't think this word problem does a great job as a sequence, quite honestly, but whatever, it doesn't matter what I think, so we're just going with what we have. So yeah, T of 0 is 10. That's how many cards were in the original box, and then the sequence starts at year 1 when he had 24 cards. So Cody plans to keep the collection for a long time. How many cards will be in the collection 10 years from now? Well, right now is year 7, so I guess they want to know 10 years from now. So we're going to plug 17 into this equation. So 17 times 8 minus 29. So 17 times 8 minus 29. So it looks like he's going to have 107 cards 10 years from now. And again, I hope you're okay with why I use 17 there, because they're saying this, we're already at year 7. So the problem I have with this problem is how much it jumps around between what's now, 3 years ago, 7 years ago, 10 years from now. So it gets a little bit confusing, I think, historically for students. And obviously myself, I got a little bit confused in this as well. Write an equation that determines the number of cards in the collection after n years. We already did. What does each number represent? So we already said, oh wait, that's for the old equation. Oh no. I think, is this wrong? Did I use the... So the equation, actually, let me go here and say this is probably wrong. The equation that we want to use is going to be 14n plus 10. That's going to be the equation that we want to use. And then if I plug 17 into this, so I apologize, I should make a note that I made an error at the end of this video. So I'm going to plug 17 times 14, and then I'm going to add 10 to that. So 17 times 14, and then I'll add 10. I used the equation from the wrong problem, my mistake. So 248 cards is how many cards he's going to have. So again, I'll make a note of that as I go through here, that I kind of screwed that up. So my mistake, I was using this equation up here, and I should have been using this equation. Anyways, what does this mean? It means there's 10 cards in the original box, and he adds 14 cards a year, is what that means. All right, 561. Trixie now wants an arithmetic sequence with a common difference of negative 17, and the 16th term is 93. So the 16th term, here's our n and our t of n. The 16th term is 93. You want a common difference of negative 17, so the 17th term would be like 17 less than that would be 76. If I moved in this direction, it would have added and gone to 110. So I hope that makes sense as to what that common difference means in terms of the sequence. Is it possible to create an arithmetic sequence to fit our information? Yeah, I mean, I think so. If possible, write the equation. All right, so how are we going to do this? Let's figure out a way to expedite this process so we don't have to do so much adding and subtracting. So at this point, you can see it's going to be really inconvenient to keep kind of adding back. So what we could do is we could say, all right, well, I know that the equation has a common difference of negative 17, right? And we've used this strategy previously this year in different contexts. So I'm going to subtract 17, and I just need to know what my starting point is. Well, I already have an n and a t of n. I can use any of these 3 points that I've already calculated, but let's use 16 and 93 since that's the one the book gave us. So I know my t of n is 93, and I know that my n is 16. And it will give me my b, or my zeroth term, if I calculate this. So what I'm going to do is I'm going to multiply a negative 17 by 16. So negative 17 times 16 is going to give me negative 272. So now what I need to do is add 272 to both sides, and that will give me my zeroth term. So it looks like 365. So my equation on this one is going to be t of n is equal to negative 17n plus 365. And again, we've already done this kind of a thing where we solve for the starting point with a slope and a point. So hopefully that makes sense to you and it wasn't too tricky to do that. A lot of good questions in this section for sure. All right, so 562. I guess I'm confused. Is this like a one-day lesson or a two-day lesson? This is taking some time here. All right, so 562. We're gonna go, and it says your favorite radio station WCPM is having a contest. The DJ poses questions to the listeners. If the caller answers correctly, he or she wins the prize money. If the caller answers incorrectly, $20 is added to the prize money, and the next caller is eligible to win. The current question is difficult. No one has won for 2 days. Lucky you, 14 people already called in today with the correct answers. So when you called with the right answer, of course, you won $735. How much was the prize at the beginning of the day today? So DJ poses the question. Okay, so the 14th call, again, I need to clear some room here. Uh-oh. Got a feeling this video is going to be way longer than I intended. I apologize. There's so many questions in this one that takes so long. All right, so every time a caller gets it wrong, they add money. So it looks like the 14th term, right? We have our n and our t of n. The 14th term was 735. And we know that the n is 20, right? So if it had gone to 15, it would have been 755. And if it had at 13, it was 715, right? So that's kind of what we're looking at. So we're just going to use the equation t of n equals 20n plus b. And again, we'll take this data. This is 735. and we will get 735 equals 280 plus b. We'll subtract 280, and then b is going to equal 455, I think. So my equation, I'm sorry, so it started today at $455. That was the zero term. And suppose the contest always starts with $100. How many people would have to guess incorrectly for their winner to get 360? So, different question here. So we will clear all this stuff out. By the way, it kind of occurs to me that I'm going to have to go through and like check the answer key on this to see if I missed anything else like I did earlier in that one. Okay, so on this one, we know that it starts with 100. Oh, we got a little bit of rain. Oh, great. Okay. So we want to know what is n when we get to 1360, right? So we're going to say t of n is equal to 20n plus 100. We already know that t of n equals 1360 in this example. So we'll get 1260, just subtract 100 from each side, equals 20n. We'll divide by 20. So 20 goes into 1260 63 times. So there would have had to have been 63 missed questions. Okay, I'm going to pause for a second, check some of my last few answers, and see if this video is a total waste. So one mess up I seem okay, so I'll just keep going now. It says Trixie is at it again. This time she wants an arithmetic sequence that has a graph with a slope of 22. She also wants t of a to equal 164. Alright, so let's see here. So we have n and t of n. We know that 8 needs to equal 164. We know that 13 equals 300. And we know that we need a slope of 22. So the ninth term would have to equal 186 and so forth, right? Because she wants to go by 22s. So the question is it possible to create this arithmetic sequence? So let's see if this is possible or not, and if it is or if it isn't, and explain why. So we know that the gap here is going to be, 136? And we know that the gap here is going to be 5. So 136 divided by 5 needs to equal 22. Oh, jeez. And it equals 27.2. So what that tells us is this, is that it can't possibly have a slope of 22 and hit on these numbers, right? If I keep adding by 22, I'm going to get 208. Then I'm going to get 230. This is kind of small here. I'm kind of running out of room. But my 12th term would be 254, and then that would mean my 13th term would be 276, not 300. So yeah, it's not going to work. It's impossible. She has the wrong slope to go with these 2 points. If she wants to make the 13th term 276, that's fine. Or if she wants to keep these, and I think it ended up being 27.2, right? If she wants a slope of 27.2, then she could keep t of 8 as 164 and 13 as 300, and then we would add by 27.2s. But we can't add by 22s and end up at 300 that quickly. It just doesn't work that way. So sadly for her, sorry Trixie, that's going to be a big no. We can't do that one for you. All right, and then finally, mercifully, to wrap up this section, write an equation for each one below. So here, it's kind of tricky. I'm just going to say I noticed that this gap is 44, and I noticed that this gap is 4, so I noticed that the slope is going to be 11. And then it doesn't matter which one we pick, so I'll take this one. So t of n equals 11n plus b. And again, 10 equals 11 times 3 plus b. 10 equals 33 plus b. So if I subtract 33, negative 23 equals b. So my equation here is going to be t of n equals 4n minus 23. Now I should be able to sub in some of these values here and get the correct answer. So if I plug in 3, 12, yeah, that didn't work out at all. So let's go ahead and see what I'm screwing up here. So let's see. My gap here is 44. My gap here is 4. It is definitely growing 11. I like that. My output is 10. So if I say 10 equals 33 plus b, I get negative 23 plus equals b. So t of n equals 11. I think I said 4 on the last one. I'm not sure what I did there. Anyways, 11 equals 23. So if I plug 3 in, I get 33 minus 23 is 10. That's good. If I plug in 7, I get 77 minus 23 is 54. So this one makes a lot more sense. I think I screwed up and put 4 in minus 23 and just went with the 4 instead of the 44 divided by 4 and got the 11. So my apologies on A. I'll make a note of that as well. I'm just not remaking this entire video. And then the next one, you can see here that as we lose 90 as we gain 30, right? So we have a slope here of negative 3. And then I'll just grab t of n and n. So t of n equals negative 3n plus b. Well, we'll say 100 equals negative 3 times 70 plus b. 100 equals negative 210 plus b, so I get 310 equals b. So my equation on this one should be t of n equals negative 3n plus 310. And now, if I plug in 100, I get negative 300 plus 310 is 10, so that works. If I plug in 70, I get negative 210 plus 310 is 100, and that works. Trixie explained, hey, arithmetic sequences are just another name for linear functions. What do you think? You know, no, there's a lot in common, but there is some differences. Like we said, they start at 1 and are discrete instead of continuous. And there are definitely some differences, although they definitely have some commonalities. Sorry the video was so long.